Monte Carlo, opulent jewel of the Côte d'Azur, a place of ancient elegance and modern fashion. A superb background for a luxury sports car captured by the camera and reproduced in the colourful sales brochure. This is the final act in the creation of a new car, the end of a long, long trail of events which began at the very heart of England, in Coventry, famous city of spires, where ancient churches and noble buildings survived the ravages of time and the devastation of war. Where the majestic tower of the old cathedral still stands as a memorial to the craftsmanship and skills of its citizens. And today, in this modern city, rebuilt from the flames, there's still the spirit of pride in a job well done. Fine new buildings and shopping precincts. Fast flyover freeways that carry the constant flow of motor cars. Reminders that this is the center of a thriving British motor industry, the parking areas crowded with cars that many owners help to build. Distinctive cars with an air of quality. Famous cars with a worldwide reputation for performance and reliability that have proved themselves against all comers in the field of international motorsport. Cars destined for the markets of the world, loaded onto the transporter at the assembly point. Triumph cars. For this is Triumph. But 1,000 skills lie between the design of a new car and the gleaming finished product on its way to the showrooms. The greatest skill must surely be in assessing future market requirements for 5 or perhaps 10 years ahead. With capital expenditure involving millions of pounds, management must make the right decisions. Nothing is left to chance, and backed by the exhaustive research of the design and marketing teams, an outline package of a new model is agreed. And the stylists go into action to decide the basic shape of the new car within the requirements laid down. Their task is to create an aesthetically pleasing outline around predetermined technical features: engine position and size, passenger and luggage capacity, length of wheelbase and power-to-weight ratio. The body styling must anticipate or lead future trends and embody the latest in engineering development. The next step is to present the design in the form of a scale model. Coach builders prepare an undersized wood base and control the shapes with templates taken from accurate working drawings. And the painstaking work of scraping away the clay down to the impressed profile gets underway. Right in the early stages, design executives explore the engineering possibilities to ensure it's completely functional. They're also responsible for the structural design beneath the skin, which determines the strength and stability of the finished car. Meanwhile, the design office gets down to the formidable task of producing the thousands of drawings needed to make up the prototype cars. Every single item is drawn out, and as each component is built, it is carefully checked against the original layouts. Here, a fiberglass model is being used to demonstrate the full effect of the life-size treatment of the headlamps. An important part of the development program is the preparation of the metal prototypes. These all-steel bodies are complete in every mechanical detail, identical with the ultimate production vehicle. Each mating part is handmade by skilled craftsmen, and the assembly is set up with absolute precision on an inspection service table. Such accuracy ensures the smooth installation of the mechanical parts during the final assembly. But long before a finished car is ready for the road, the mechanical test engineers are already at work, proving the various components and sub-assemblies. This front suspension is taking far more punishment than it would expect to meet in normal service. From the simulated test rig to the cruel Belgian pavé at the Motor Research Test Track. Through the water splash time and again, seeking to penetrate the water seals. To the mountains of Spain, in the rain. A day and night, non-stop endurance test, with the engineer crews recording every detail of the car's performance throughout the rugged schedule. Back at the Motor Research Center, through the swirling dust of the tunnel facility. Over to the open, dusty roads of Austria, in the relentless search for any seepage of dust into the interior of the car or to any of the mechanical parts. And to check the efficiency of the ventilation in the heat of summer. And to the Alps in the freezing depth of winter, where the extreme weather conditions enable the crews to assess the performance of the heater system in sub-zero temperatures. Maximum speed trials are carried out in the comparative safety of exclusive high-speed circuits and racetracks. Free of traffic restrictions, the cars can circulate at high speeds over long periods of time. But sudden deceleration is spectacular. Safety is a major consideration in all car design, and impact tests are made to prove the strength of bodies and their energy-absorbing characteristics. The strength of seats and seat belts, the effectiveness of the collapsing steering wheel and column are all monitored by a mass of electronic equipment, and the data processed by the computer for the research engineers to evaluate. This unrestrained dummy striking the steering wheel at a controlled velocity is part of the continuous search for improved safety and design. Road stability is affected by many variables: suspension, body shape, weather conditions. With a 40 miles per hour crosswind produced by a powerful jet engine, any deviation as the car passes is noted by its position on the grid. Noise, too, can create fatigue and reduce the safety factor. With the aid of a microphone and a vibrator, electronic engineers can trace and record peak resonances within the car and take the necessary action to reduce or eliminate the cause. But the noise of a dozen engines is effectively muffled in the modern test cells of the Engineering Research Building. Triumph engines have earned a great reputation for reliability and performance, a tribute to the unceasing research and development programs carried out by highly skilled and dedicated engineers. On the test bed, every aspect of engine performance is analyzed and recorded as dynamometers absorb and measure the power output under varying loads. Improved power coupled with fuel economy and reliability is the ever-present target. Smoothness means less vibration and low noise levels with longer engine life. On long endurance runs, the arduous cycle of tests can be remotely controlled by special sequence control equipment, operated by punch tape. Any series of tests can be programmed and automatically carried out by the sequence controller. In the laboratory, gas chromatography is used to study the combustion and air pollution characteristics of a development engine. Over 200 different hydrocarbon components can be separated at a temperature of minus 78 degrees centigrade. Gas chromatography is also used to analyze non-metallic materials, such as rubber, plastics, adhesives, lubricants, brake fluids, etc., to ensure the highest quality and freedom from any detrimental effects to the customer or his vehicle. Paint finishers of different manufacture are subjected to accelerated weathering in a special machine which bombards the samples with intense ultraviolet and infrared rays. Liquid paint is tested to establish the correct viscosity suitable for spraying by timing a measured quantity as it flows through a nozzle at the base of the cup. Hardness of the paint surface can be assessed with this device by counting the number of pendulum swings as friction slows the rocking until the pointer coincides with the stop indicator. Another machine, the indentometer, measures the hardness of foam cushions to control the quality and maintain the luxurious comfort of Triumph upholstery. Components manufactured by outside specialist suppliers arrive on a controlled delivery schedule which is linked with production. Before passing to the machine lines, a percentage of the cylinder blocks selected at random is inspected by the quality control team. Should any be faulted, they're rejected before any machining has taken place, a saving in time and money. Using precise measuring equipment on the clinical surface of the inspection table, an exhaust manifold casting passes through the stringent quality check before it's released to the machine shops. On the production lines, a constant check is carried out at all the machining stations to ensure that the work is within the tolerances laid down. The design and installation of the machine lines to cope with volume production is a gigantic task. Many automated processes need specialist machines, as with the vertical boring and honing of the cylinder block. As each operation is completed, the block passes to the next machining station. After honing, the blocks pass to the high-precision Sigma machine, which automatically measures the bores for size and shape, working to a tolerance of 1/2 of an inch. Cylinder blocks, which do not conform to these limits, are rejected immediately by this inbuilt quality control. Many of the smaller items that make up a gearbox are also machined automatically. With various machines linked together by a moving slat conveyor, the components travel from one operation to the next, cutting, chamfering, honing, all loaded and ejected from the machine untouched by hand. Until the inspection station is reached, where the gears are placed on mesh and checked for concentricity. Every Triumph crankshaft is dynamically balanced to fine limits. Drilling the crankshaft to achieve this balance is highly skilled work, calling for experienced judgment and great accuracy. The responsibility for maintaining the accuracy of the precision equipment in use throughout the factories lies with the standards room. Here, the most precise measuring devices available are housed in an air-conditioned and temperature-controlled environment. This shadow graph projects onto the screen an optically enlarged image of the component profile, which is checked against an engineering drawing of the same magnification. A matrix taper measuring machine, accurate to 1/100th of 1/1000th of an inch. Operated by micrometer adjustment, this measures the angle of taper of a component. The greatest accuracy is achieved by this Taliron machine, capable of measuring within 2/millionths of an inch. Its purpose is to record irregularities of form and errors of roundness, and can operate on internal or external diameters. Meanwhile, in the body section, the many steel pressings are assembled into the welding fixtures, and the body shell takes on a more recognizable form. In the master control room, every section of the paint shop complex is monitored, and the halting of any track is immediately shown up on the indicator panel. The unpainted bodies are marshaled on a system of automated roller tracks to commence the journey through the various stages of the painting process. After phosphating to prevent the formation of rust, each body shell is coated with primer. This is applied by the electrophoretic process, which deposits an even coat on all surfaces, including normally inaccessible boxed-in sections. 2 coats of grey primer follow, each carefully rubbed down by hand to form a flawless base for the final color. 2 final coats of the chosen color are sprayed on by hand in an atmosphere entirely free from dust. The engine and gearbox unit, already inspected at the manufacturing plant, is again thoroughly checked at the assembly hall, and so begins the final journey along the main assembly track. All the careful planning and research, the precision manufacture and rigid inspection culminate at this stage in the rapid assembly which proceeds like clockwork. Power tools are used extensively, and the multi-spindle wrench tightens all the wheel nuts simultaneously to the correct tightness. The cars progress slowly along the track on their own wheels as the final adjustments are made. At the inspection stage, doors are checked for correct fitting, and the window winders for smooth operation. All the lights and other electrics are systematically tested. The paintwork receives a last careful scrutiny to detect the slightest blemish that would mar an otherwise perfect finish. But this is not the end of the story, for research and development never ends. One of the most urgent problems facing all manufacturers of internal combustion engines is the control of the noxious exhaust gases emitted into the atmosphere. To comply with legislation laid down by certain overseas markets, the cars must pass through the Emission Control Department. Here, in a clean air and temperature-controlled atmosphere, the exhaust gas analyzers linked to a computer can separate, analyze, and measure the exhaust emission. In this completely isolated building, the excess exhaust fumes are withdrawn through an extractor below the floor. An extension is fitted to one of the exhaust pipes, and to this a small tube is attached. Through this tube, pumps draw off the required sample of gases for analysis. Through headsets, the driver and the control technician maintain close communication throughout the test. Starting from a cold choke condition on the roller road, the vehicle follows a driving cycle in line with the computer. This simulates a typical drive of about 1 mile through an average city, with controlled speeds and gear changes, from an idling speed up through the gears to a steady 30 miles per hour, down to 15, steady, then rising quickly to 50 miles an hour. At each of 7 speed changes, 4 gases are separated, analyzed, and measured, and the complete cycle is repeated for 7 consecutive times. Finnish cars are still subject to a stringent overcheck procedure carried out by the experienced engineers of the investigation department. With a roving commission, these special investigators have the authority to take any car before it passes to the sales division and make a thorough search for any defects, however slight. The car is driven over a special test course, and every detail of its performance and handling is written into the report. Minor adjustments are made on the spot, and any faults are noted for rectification back at the factory. Should a similar fault occur on more than 2 cars, a major inquiry takes place to discover the reason. Mechanical faults are traced to the source, even if this means dismantling right down to the last nut and bolt. This is quality control with a vengeance. The investigation continues with methodical thoroughness. Brakes are checked for binding, and the wheel bearings for end float. With the Optoflex measuring device, the caster camber and kingpin alignment are checked within fine limits. Water seals are checked for leaks by passing under a framework of high-pressure water jets. These create a cloud of fine spray capable of penetrating the smallest gap. Over to another kind of jet at Geneva Airport, where the motoring pressmen arrive to put a new Triumph car through its paces. Here, the first production models, not yet unveiled to the public, await the critical appraisal of the press. Triumph's top executives welcome the journalist to this private preview, the most important event in the pre-launch program. With confidence, the cars are offered to these most discerning critics for their impartial opinions to be communicated through the news media to the motoring public. And on the unrestricted autoroutes of the continent, they set off to assess the qualities and the performance of this latest addition to the range of quality cars from Triumph.